and welcome to our presentation. My name is Juan Ospina Gonzalez, and together with József and Vesza, we'll look at how you can leverage Combine to wrap yours or a vendor's API.
We'll start with a short intro on Combine's components, and then dive into a custom publisher implementation. Finally, we'll finish up by covering our implementation with unit tests. Let's get started.
First, let's examine the benefits of using Combine for your APIs. Instead of looking at it strictly from a declarative versus imperative perspective, consider the asynchronous communication patterns that are currently present in your apps. Chances are that you have probably used most, if not all, of the following: notification center, delegation, operations, closures, timers, KVO. It is also very likely to have more of them coexist in the same codebase. Sometimes it's our choice. A delegate may be more desirable than a notification. Other times it happens due to the frameworks, either first or third party, that we work with. Combine adds another tool to our async arsenal, but it's also much more. It can be used to unify all of our asynchronous communication, so it can look like this. The intent is clearly there from Apple. Along with Combine, they also extended their more traditional APIs with Combine integration. In this session, we'll look at how to leverage Combine to unify the APIs of the AB Foundation framework. Why AB Foundation? Well, it's a living example of a framework communicating via different methods. When you're doing a video player, you're usually doing KVO to track the status of AB player item, and maybe notification center to observe the AB player did play to end event. And even some custom API, like this call to add a periodic time observer that keeps track of the playhead's progress. Wouldn't it be nice if it offered a set of Combine publishers to cover everything? Before we dive into more complex stuff, let's start with a few simple examples. Turning a KVO-backed event into a publisher is pretty easy, since Apple extended NSObject with a publisher that fires whenever a property is updated. Likewise, with Notification Center, you can create a publisher that emits events when notifications happen. But what about custom APIs like that periodic time observer shown before? That case requires a bit more work. We'll need to create a custom publisher to wrap it. But to better understand the work needed, let's take a step back and look at the building blocks of Combine.
In this section, we'll take a look at Combine's key components: the subscriber, the publisher, and the subscription. Let's start with publishers. A publisher is a type that delivers values over time to one or more subscribers. Combine also offers operators, which are publishers themselves. They receive data from other publishers, manipulate it, and send the results downstream. Next up, we have subscribers. They receive values from publishers, along with lifecycle events, such as completion. Combine offers two built-in subscribers: async, which executes arbitrary work as events occur, and assign, which allows you to bind the output of a publisher to some property. It is also possible to create custom subscribers, which we'll look at later. Finally, we arrive at subscriptions, which bind the publisher and the subscriber together. We'll get back to subscriptions in a minute. Working together, these components follow a certain sequence of events. First, the subscriber subscribes to a publisher. In response, the publisher creates a subscription and passes it back to the subscriber. The subscriber can then demand values from the subscription, which prompts the start of async work. During its lifecycle, the subscription will send values to the subscriber and eventually complete. Before opting for a custom publisher, it's worth considering if that's the best approach. There are a few alternatives to consider. You could use the add_publish property wrapper, or use a pass-through subject instance to send values on demand. In this session, however, we'll build one from scratch. Let's start by declaring a publisher. The first thing to do is to define its output and error types. This publisher will emit the playback progress and no errors. Next, the publisher needs to be able to accept subscribers. One important thing to note here is that the subscriber's input must match the publisher's output, and the error types must match as well. To finish that method's implementation, let's take a moment and think back to the sequence of events. When someone subscribes, the publisher must create a subscription and pass it back to the subscriber. So now, it's a good time to implement that subscription. Let's have a look. The subscription is where most of the work will happen. This might seem weird at first as you work with publishers most of the time. So what makes subscriptions special? Well, they offer API for demanding values, which should be a trigger to kick off any work that needs to be done. Whenever a subscriber is ready to request values from the subscription, it invokes its request method, passing in the demand as a parameter. Demand is the number of values the subscriber wants. It can be a fixed number or unlimited. Let's implement that method now. First, we need to keep track of a few properties. The subscription needs a reference to the subscriber. We also need to keep track of the number of values requested. The time observer token is required for the wrapped AV Player API. Lastly, we'll need to have reference to the AV Player instance to work with. This will be passed during initialization. Now let's look at the method implementation. When a subscriber sends a demand, it can specify how many values it wants. The subscription is responsible for keeping track of this, so it'll increment the current demand with a new value. Then we check if the work has already started. A publisher should work lazily. No work should be performed until there are subscribers. At this point, we note that there's a demand, and we haven't started the work yet, so it's time to kick things off. We'll use the API provided by AV Player to request periodic progress updates. When a progress update is ready, we first check if there's still a demand. We only want to send as many values as demanded. Then we decrease the demand to account for the value we're about to send. Then we pass the progress value to the subscriber. At this point, the subscriber has a chance to update the initial demand, which we need to take into account as well. Now our subscription knows how to produce values, but cancellation still needs to be implemented. So let's look at that. This method is our chance to do any cleanup. Here we invalidate the time observer and nil out a reference to the subscriber. And with that, the subscription is finished. It's time to pass it back to the subscriber. Let's go back to our publisher implementation and update it. As mentioned before, the publisher creates the subscription and passes it back to the subscriber. Now, before wrapping up our publisher, I would like to take a moment and briefly mention thread safety. Combine's documentation is a bit absent on the matter, but there are some rules to follow. The receive subscriber method can be called from any thread. Downstream calls to the subscriber's methods can come from any thread, and they must be serialized. Upstream calls to the subscription's methods can also come from any thread, and they also must be serialized. The simplest way to adhere to these rules in our publisher is to apply locking in the following situations. When receiving a demand, when emitting values, and also when cancelling the subscription. Playing it safe like this can save you from multi-threading headaches. Now our publisher is ready to be used. Let's wrap it in a nice extension to provide easy access. And with that, we can use it in our app. And with that, our custom publisher is done. Or is it? Sure, it works well with a sync, but does it handle demand changes? Is it truly lazy? If we look back at our subscription, it becomes obvious that it's the cornerstone of our implementation. Forget to decrease the demand as values are sent, and you'll end up sending more values than requested. And if you disregard demand updates, the subscription can end up delivering less values than needed. There is no automatic behavior you can rely on to do this, and the manual bookkeeping can be error-prone, which is why it's always good to back your custom publishers with unit tests. In the next section, we'll take a look at how to do that. When it comes to testing, we need to verify 3 different scenarios. The first is unlimited demand. The most common use case for publishers is to subscribe using sync and handle values as they are emitted. Next up is fixed demand. It could be that the subscriber wants to limit the number of values emitted by the publisher. Your tests need to verify that the publisher emits the correct amount of values. And finally, there is dynamically changing demand. A more advanced scenario is to update the demand during a subscription's lifetime. This can be useful for heavier tasks, where the publisher emits so many values that the subscriber has a hard time keeping up. First, we're going to need control over the playback progress updates. So we'll use the following mock implementation. This mock is a subclass that allows us to hook into the same API our publisher relies on. By capturing the update closure, we can manually send updates with arbitrary values. Let's test the first scenario, unlimited demand. This is the easiest to cover. When you use the built-in sync subscriber, the demand will be set to unlimited. So it's easy to set up a test in just a few lines. The test uses a sync to collect values received over time. In the end, it compares the received values with the expected ones. Since we control the updates, everything happens synchronously. There is no need for async expectations. Now, with the simple case out of the way, let's look at something a bit more advanced. In order to gain more control over the demand, we'll need to implement a custom subscriber. If you recall, subscribers can set the initial demand and also update it as values are requested. We'll leverage these abilities to control the demands in our tests. First, let's get the boilerplate out of the way. You might recall that the subscriber's input must match the publisher's output, and the errors must also match. So we'll use time interval and never, just as in the publisher. The initial demand will be passed during initialization. The value handler closure will be invoked when the value is received, so we can check the values in our tests. And finally, we'll keep a reference to the subscription. This is important. The subscriber needs to keep a strong reference to the subscription to keep it from deallocating prematurely. To conform to the subscriber protocol, our implementation needs to handle 3 scenarios: receiving the subscription, receiving the values, and receiving completion. Let's look at them one by one. You might recall that our publisher configured and passed the subscription to the subscriber by the receiveSubscription method. So let's implement that method first. Nothing special yet. We retain the subscription and kick off the work by requesting a fixed number of values. The subscription will invoke the receive method when it produces a value. It is our chance to process the value and optionally update the demand. Here we call the value handler closure with the new value and leave the demand as is. Finally, when the subscription completes, receive completion is called. Here we just clean up. So now we are ready to run a few more tests. The next one will cover the case where only a few values are requested. The setup is quite similar to the previous test, but note that instead of a sync, we are now using our test subscriber instance with a demand of 2 values. In this scenario, our publisher must produce exactly 2 values. With a slight change, we can also verify that our publisher is lazy. When the initial request is 0, it won't emit any values. There's still a gap in our test coverage. We need to verify that our publisher behaves well if the subscriber decides to update the demand dynamically. To have even more control over demand handling, we'll update the value handler closure in our test subscriber implementation. Now our tests will have a hook for updating the demand. One important thing to note here is that you cannot decrease the initial demand. So if initially 2 values were requested, the subscriber will get those 2 values. It then can decide to not alter the demand or request more values. Okay, now it's time to implement our final test. When the first value is received, our subscriber will request another one. Otherwise, no additional values will be demanded.
In summary, we cover how you can create a content publisher from scratch. Along the way, we also created a custom subscription and a custom subscriber implementation. We hope this knowledge will serve you well when you work with Combine in the wild. And remember, if you choose to go for this type of solution, remember to always check your error cases with some tests. To see the full implementation in context, check out our GitHub repo. If you have questions, feel free to reach out to us on Twitter. And if you want to read the written summary, I highly recommend you have a look at these kick-ass articles in József's blog.